Okay, hi everybody. So in this video here, we're going to do what it says here. We're going to construct and simplify the difference quotient, which is this f of x plus h minus f of x all over h. We're going to do that for this expression x cubed. Now this is important in calculus. This expression or this difference quotient is really important, kind of a springboard for the calculus course here. What we're doing with it right now is we're looking at it really just as an exercise working with functions and making sure that people understand how function notation works. Because it's when we start doing like f of x plus h and then together with another f of x, I've seen a lot of students kind of get confused by that. So I want to make sure that we give you some examples to work with. Now, so we're just going to jump right in here. So when we say f of x plus h minus f of x all over h, in this case here, because f of x is x cubed, it cubes whatever's within the function notation here. F of x plus h is going to mean x plus h cubed. And then I can replace f of x with just x cubed. And this is still all over h. Now, you might look at it and think, well, okay, I think I'm done. I've just substituted things in there. But we do want to simplify this a little bit. And I'm going to let you know there is a really natural stopping point to this. So this isn't one of those places where you're sort of left guessing as to what we intend by like where the end point is. It's going to be quite clear. So I've got x plus h cubed. Now, from a previous course, you should have looked at binomial expansion here at this point. If you're looking at this if you're looking at this question here, this video here, you've probably seen that before. X plus h cubed is going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. And then we've got that minus x cubed at the end there, okay, right there. And then this is still all over h. Okay, and that's just me applying binomial expansion for a cube. There are other videos out there to show you how to do that if that's confusing at all. Now, but notice what happens here immediately. I've got this x cubed and this negative x cubed, and they cancel. And what's significant about that is what you're left with is an expression in the numerator that has h as a factor. So I can take out the h, and I'm left with 3x squared plus 3xh plus h squared. And this is all over h. And then those h's cancel. And this is the natural stopping point for us. 3x squared plus 3xh plus h squared. As soon as we've canceled out those h's, we're done. Now, does my final answer have h's in it? Yeah, but not as a factor in the denominator. That's gone. And that's important here. Now, based on other work that we've done, you would be very tempted to say, okay, that's true as long as h doesn't equal 0. You're going to see when you get into calculus here that that's not such a big deal to mention that because there's an operation we're going to do that's going to kind of deal with that. But anyway, this is the expression that we're looking for.